below, which means that the data that we've collected is about 92% accurate for the next forecast. And then the tracking signal is right in the middle, so it doesn't show a difference. It's not overestimating or underestimating the demand. So next we go on to the drug-eluting forecasting accuracy. And again, we did the same 4 methods that we did prior. In this method, we chose that the trend and seasonal method worked best. It has the lowest of all 4 numbers. The only outlier is the tracking signal, but that makes up for it in the R-squared formula because about 50% of all of the data points and variations are accounted for through the R-squared. And since the number of drug-eluting stent procedures are less steady, there's more demand volatility, so seeing the trend and seasonality of the data makes more sense. So this also shows you our seasonality. As you can see here, we did 4 quarters and found a scaled seasonal index from the trend and seasonal method. And you see here in Q2 and Q3 seem to have the bigger seasonality index, which means that, to me, that most of this procedures are done between the 2nd and 3rd quarter of the year, and that it starts to pick up in the 1st quarter, and it's less than the 4th quarter, which shows that there's a trend to how many procedures are done and how many stents are used throughout the year. You can see that there. Okay, so on to our second topic. This is our inventory modeling. So we took the bare metal stents, where you can see a stable demand, low volatility, and a constant lead time, compared to the drug-eluting, which has variable demand, uncertainty, but also a constant lead time. So this would lead us on first observation of the data for the bare metal stents to use an economic order quantity model versus a continuous review model for the drug-eluting stents for inventory modeling purposes. So you have an overview. Their current inventory modeling policy is that they reorder their drug-eluting and bare metal stents. Drug-eluting in lot sizes of 9, bare metal in lot sizes of 3, and they order them on a daily basis. It takes the manufacturer 48 hours to get the stent to the cath lab. And this policy was implemented to reduce cost, which our findings say it does reduce cost, but there's also other issues with it. The first is, even though that they are frequently ordering to reduce costs, they have a very, very small margin of safety stock for the stents, usually between 1 and 2 stents a day. And so if you were to have an emergency come in and needing to do a stent procedure, there might be an option that you're not going to have the stents readily available. And they're heavily reliant on a tight delivery schedule from the manufacturer. So hopefully nothing happens where you don't get the stents on time. So this is our preliminary analysis of our drug-eluting stents. As you can see here, we use all 8 quarters of the 2 years. This is our quarterly demand usage, so these are the actual numbers that we got from the hospital. And we converted those quarterly demands into daily demand numbers. So it ranges between 9 and 10 stent procedures on a daily basis. The first problem that you see here is that the lot size is 9. So if you were to use 10 stents on one day and you can only order 9, you're down by 1 for the reorder point, which is 23. And they're running a safety stock of about 3 per day. So if you look at, they have a very little margin of error because you can't really catch up with the way that the stent procedures are done on a daily basis. And if you look at Q2, it kind of shows that. So take, for example, if it was Monday morning and you had 10 procedures, and then you go and order them, and you only get 9, you're down to 22, but your reorder point is 23. So you're already below, so you're going to have to continually monitor and reorder and reorder and reorder. So going on to the bare metal, you see the same issue. Again, we took the daily demand, which is between 1 and 3, depending on the quarter. With the lot size of 3, and then your safety stock at 95% service level is between 1 and 2 stents per day. but your reorder point is 7. So you're still going to be below the reorder point on a daily basis if you were to meet the daily demand of 3. So with that being said, we think for at least the bare metal stent, since it has more of a steady and constant demand, that you could use a basic EOQ model to better handle the demand for this type of stent and hopefully reduce the cost more than what you already have. So this is our preliminary EOQ model. I want to point out this is very, very, very basic. Like I said earlier, it's hard to get the actual information on what the fixed costs per order are. And we estimated the holding cost to be about 20% for each order, which is how we got the 160. Yeah.
A yearly holding cost, 20%?
Per quarter of 160. So we see here from the preliminary EOQ model that the stents can be ordered in larger lots and at different variables. So if you were to look at Q2 of 2009, you would need to order them 12 times per quarter instead of every day. So instead of 65 orders, you're doing 12 orders of 15 stents, and you're still going to be able to reach the quarterly demand of 199. And then the other option is that the stents definitely go up from 2 to 3 per order to 11 to 15 per order. And then it cuts down, like I said, it cuts down the number of orders from between 9 and 12 instead of on a daily basis, which should reduce the cost. But we didn't want to put any cost information up there because we don't want to estimate. We want to get some real information, which is a future topic of study. So our preliminary observations, just a review, is that they still have a heavy reliance on a tight delivery schedule. That with an inefficient inventory management based on the current ordering policy, they're in a constant state of reordering instead of being in a constant state of having enough supply for what they do. And they need to examine a broad selection of inventory control models that could design a customized model that integrates both the demand forecasting and the inventory modeling. And it also allows for the sensitivity analysis based on performance metrics, such as how much their service level of the hospital and all of that. Next. So out of all of that, it was probably really quick. Our first conclusion was that they needed to tailor their inventory ordering policies to the historical trend and the forecasting method. For forecasting method for drug-eluting was the trend in seasonality, so looking at the seasonality of the forecast, and then also for the 4-point moving average for the bare metal. We did decide that they need to manage the drug-eluting stent inventory a little bit more tightly than the bare metal because the increased cost of the product is about on average about $1,800 per stent. And they also need to ensure minimal risk of being out of stock since that's the stent that is used on the most often. So based on all of that, we decided that for the drug-eluting stents, you could use a continuous review model due to the uncertainty in the data, and then a basic EOQ model for bare metal stents due to the more stable demand. Our future work, we want to integrate the function of forecasting inventory functionalities to make it an auto-replenishment system where the minimum and the maximum levels are specified ahead of time and the inventory is replenished as soon as that level is reached. And then also to have a customized inventory management, use inventory models and historic product data so that they're continuously examined not only by human error, because there's human error, but also by a computer. And the new order should automatically be placed as soon as the actual inventory falls below the predetermined levels. And also the next is to use business intelligence, and in order to examine and adjust the minimum and maximum, we need to avoid the maximum level falling below what is required, so it indicates a shortage. Examining the minimum level so it's not giving you a surplus of stents, and then also to prevent the increased costs to the organization.